Welcome to the Screencast-O-Matic video version of the Calculus Volumes project. I'm going to work problems 2D and a variation of 3E so that you have some examples to go by. Okay, so problem number 2D had curves. We had an x squared plus 2 curve and a y is equal to 3x curve. So our little wedgie that we're going to find the volume for is here. And this problem has us taking slices perpendicular to the x-axis. And our vertical shape is isosceles right triangles. Okay, so if we look at this from not from the bird's eye view, which is what we see here, but we're going to look at those isosceles triangles as they're rising up off of the page. So it's not quite an isosceles triangle, but let's run with that. Okay, so the distance between the two curves is, our two curves are y is equal to x squared plus 2 and y is equal to 3x. So this distance between the top of the curve and the bottom of the curve is x squared plus 2 minus 3x. So we need to know what the area of these triangles is, and if we split those in half, then area is equal to 1/2 base times height. And as Alan so obnoxiously and correctly challenged me, this distance here, the base, is going to be x squared minus 3x plus 2 over 2, because that is the halfway point. And therefore, if this is also, if the whole thing is an isosceles right triangle, then this is also an isosceles right triangle, so that's a 45-degree angle. So the height is also x squared minus 3x plus 2, all over 2. So the area of this isosceles right triangle is 1/2 times the base, which is x squared minus 3x plus 2 over 2, times the height, which is also x squared minus 3x plus 2 over 2. So this ends up being 1/8 x squared minus 3x plus 2 quantity squared. Okay, so we're going to integrate the area. We're going to integrate all those little isosceles triangles and we're going to compute the bound in a second, but we're going to say 1/8 x squared minus 3x plus 2 squared dx. So let's compute our bounds of integration. So for the bounds, it's going to be where 3x and x squared plus 2 intersect. And so we're going to set the two y's equal to each other. So x squared plus 2 has got to be equal 3x where they intersect. So x squared minus 3x plus 2 is equal to 0. And as Libby got, x minus 1, x minus 2 is equal to 0. So x is either going to be 1 or it's going to be 2. And since our bounds are with the x-axis, then we've got to choose that little wedge. So we've got to choose this point, which is, of course, x is equal to 1. So x is equal to 2, of course, is where is the other location where those two curves cross. Okay, so our upper bound of integration is going to be 1, and our lower bound of integration is going to be x is equal to 0. Okay, so we are almost ready to take that integral, but this is going to be one ugly piece of business here. We're going to do an extended FOIL, or actually we're going to use the box method and get all those coefficients, but x squared minus 3x plus 2 quantity squared is actually one big hairy polynomial. So let's go to another page, and I'm going to use the box method because that's, to me, that's what is the easiest thing to do. And so we've got x squared negative 3x and positive 2 here. So we multiply each one of these, that one times that one, to get what fills in here. Negative 3x cubed, 2x squared, negative 3x cubed, negative 9x squared, now that's a positive 9, and negative 6x and 2x squared minus 6x plus 4. So when we combine all those like terms, that's a 4. And we're going to add down the diagonals. Minus 6x cubed. 2 plus 2 plus 9 is plus 13x squared minus 12x plus 4. So we're going to go back to our other page and fill all of that in. So let me see if I can make it back there with a brain. So when we expand this out, 0 to 1, 1/8 times x to the 4th minus 6x cubed plus 13x squared minus 12x plus 4 times dx. Hairy, but easily doable. Okay, so let's do our integration. I have, oops. Okay, realized I made a mistake, which you probably caught. The base, of course, is not 1/2. It is the entire base of this triangle. So the height is 1/2, but the base is the full base. So I bet there were a couple of you that were squawking, and I luckily was not there to see you. So we're going to correct that to be a 4th, and that to be a 4th, and that to be a 4th. Okay, so we're going to say 1/4 and integrate these terms across. 1/5 x to the 5th minus, if we increment that, that's over 4. 6 over 4x to the 4th plus 13/3 x cubed minus 6x squared plus 4, and all of that is from the bounds 0 to 1, so we don't have to worry about the 0 side. 1/4, and that ends up 1/5 minus 2/3 plus 13/3 minus 6 plus 4, and all of that multiplied together comes out to be, divided by a fourth, or multiplied by 1/4, 31 1/20ths. If you would like to confirm that on your calculator, I would invite you to do so. Okay, we're going to get partway through the next problem, which is going to be a dy problem. And I'm going to do a modification of the problem that I have on your sheet, because I don't want to give the 3E people the advantage. So we're going to take we're going to find the volume. We're going to use y is equal to cubed root of x, and between x is equal to 0 and x is equal to 8. And we're going to, between curve and x-axis. But we're going to do something a little bit different. Instead of taking slices that are perpendicular to the x-axis, we're going to take slices that are perpendicular to the y-axis. And those slices are going to look like this. And so what we'll be integrating over is dy instead of dx. And our shape is a rectangle that is twice as long as it is wide. So if we look at those rectangles rising off that xy plane, we're going to have the bottom dimension, which we're going to have to calculate. That is this length here, which is, if this is x is equal to 8, then this length is from x is equal to 8 to where the curve hits it, but we need that in y. So if y is equal to cube root of x, then y cubed is equal to x. So we're going to say it's going to go from here to here, but that is y cubed. And therefore the height of these things is 2 times 8 minus y cubed. And so the area of that rectangle is 2 times 8 minus y cubed squared. So we're going to integrate, and we'll deal with the bound in a second. 2 8 minus y cubed squared dy. So everything has to be in y because we are integrating over dy. So tune into the next video to find out how the story comes out.